Hi there and welcome to another video from HEGARTYMATHS. It's Mr. Hegarty here, and in this video we're talking about linear sequences and nth terms. So in this video we'd like to be able to describe a linear sequence, to find the next few terms of a linear sequence, to find the nth term, and to use the nth term to find a term in the sequence. So we're going to do all that in this video, and we're going to do it in a few examples. Firstly, what's a sequence? Well, sequence comes from the Latin word sequi, and it's to do with following, like a sequel follows the previous film. Or non sequitur actually means something that does not follow. So sequences are, well, what are they? They're a list of numbers that follow a pattern. And that's all a sequence is. So that's all you need to know from maths, and it'd be nice if you knew where the word sequence actually derives from. Okay, so I'm going to show you all the types of questions that could come up by way of an example. So imagine we had the following sequence: 6, 11, 16, 21, 26. The first thing that you could be asked is, they would ask you, what's the rule of the sequence? Okay, and you can see that each time you're adding 5. Okay, so the rule would be add 5 each time. Okay, simple as that. So that's the first thing you could be asked, and that's the easiest thing. The second thing you could be asked are, what are the next 3 terms? Sometimes the examiner likes doing that. Well, if you add another 5, you would get yourself to 31, add another 5, 36, and add another 5, you get yourself to 41. Okay, so all you've got to do is continue the sequence by adding 5. Nice and straightforward there. Okay, right, the next thing that you could be asked, what's the nth term? What's called the nth term of a sequence? And what the nth term is a formula that tells you what the term in the nth position is. So for example, you could use it to find what the 17th term is, the 100th term, the millionth term. It's a formula that you can substitute n as a number into it, and it would tell you what the term would be. So here, this is the first term, this is the second term, this is the third term. What if I wanted to know the 116th term? If I had a formula to do that for me, it would be really helpful, and that's what the nth term is. Okay, so each time you can see that the sequence was going up in 5s. Okay, each time it was going up in 5. Now, in order to find the nth term, what you do is you think, what other sequence of numbers or multiplication tables goes up in 5? And they're the 5 times tables. So above it, you would write the 5 times tables. 5, 10, 15, 20, 25, 30, 35, 40. In general, the nth term of the 5 times tables is 5n. Okay, 5 multiplied by a number. Because in this case here, it's 5 multiplied by 1. Here it's 5 multiplied by 2. Here it's 5 multiplied by 3. You get the picture. So the nth term, this is the first, the second, the third. The nth term would be 5 multiplied by a number. Now, what's our nth term? Well, all our numbers, 6, 11, 16, are 1 more than the 5 times tables. So the nth term must be 5n add 1. So we could write in here that the nth term is 5n add 1. Okay? Now, what could you be asked now? You could be asked 2 things about the nth term. They might ask you something like, what is the 13th or the 100th term of the sequence? And it's nice and easy. All you have to do here, having got your formula, you substitute n is 13 in. So 5 multiplied by 13, add 1. You would work that out, and that would give you that, in this case, the 13th term would be equal to 61. And if you substituted 100 in there, you would substitute 5 multiplied by 100, add 1, and you would know that the 100th term was actually equal to 501. Okay, so that's what you could be asked. The very last thing you could be asked, let's just extend the page, the very last thing you could be asked, they might ask you, a question and they would say something along the lines of is, let's say, I don't know, 103 a term in the sequence, and they might ask you, is something like, I don't know, 111 a term in the sequence. So they would ask you whether those are in the sequence or not. Now you could go back to your sequence and keep counting on by 5, but that's not a really useful method. Instead, if it was a term of the sequence, you could let your nth term, 5n plus 1, be equal to 103. If you could find n, a whole number, n always has to be a whole number, such that this equation hold true, then you would know that it is a term in the sequence and it's whatever n is. So how could you see if this is true? Well, you could subtract 1 off both sides, so that 5n must be equal to 102, and divide by 5, so n is 102 divided by 5, and it turns out that n is therefore equal to 20.4. Now n has to be a whole number, it's a decimal here, so therefore 103 is not a term in the sequence because it had to be whole. Therefore the answer is no, 103 is not a term. What about 111? Let's check. Well, we could let 5n add 1 equal 111, subtract 1 off both sides, 5n is equal to 110, n would therefore be 110 divided by 5, and that would be equal to 22. Therefore, is 111 a term? Yes, the answer is, it is the 22nd term. Okay, and that's about all you could be asked about sequences. Right, let's do another one. Here's another sequence. So, firstly, what's the rule? Well, the rule is add 8 each time. So, add 8 each time is the rule. What are the next, let's say, 2 terms? So what are the next 2 terms? Well, if you add 8 on here, you would get yourself to 42, and you add another 8 on here, it would be equal to 50. Okay, so therefore they're the next 2 terms, so 42 and 50. Then you might be asked, what's the nth term? Okay, so this is going up in 8, so let's write the 8 times tables above it. 8, 16, 24, 32, 40, 48, and lastly 56. So the nth term of the 8 times tables is 8n. So what's the nth term here? Well, our sequence is always 6 less, so our sequence must be 8n subtract 6. So the nth term here is 8n subtract 6. You might be asked what's, let's say, the 20th term, and you would do 8 multiplied by 20 subtract 6, which is 160 subtract 6, which is 154. So that would be as simple as that. And lastly, you might be asked something like, is 172 a term? So you would let 8n subtract 6 equal to 172. Add 6 to both sides, 8n would be equal therefore to 178, and therefore n would be equal to 178 divided by 8, and you would check that on your calculator and you get yourself 22.25, which is a decimal. N had to be a whole number, so therefore no, 172 is not a term. Simple as that. Okay, one more example, slightly more complicated with negatives. So imagine you had this sequence here. First thing you might be asked is, what's the rule? So the rule is each time you're going down by 2, so the rule is subtract 2 each time. You might be asked what the next 2 terms are. Well, subtract 2 would be negative 2, subtract another 2 would be negative 4. So negative 2, negative 4, negative 6 are the next, let's say, 3 terms. You might be asked now for the nth term. Now this is slightly more complicated. You're going down in 2. So I'm going to write the -2 times tables. -4, -2, -4, -6, -8, -10, -12, -14. Now the question, so in general, the nth term is -2n. So how do I get from here to here? Well, from -2 to 8 is you add on 10. So let's just check it's true here. If you add 10, you get from -4 to 6, that's true. And in particular, this one's probably the easiest. To go from -10 to 0, you add 10. So our nth term is -2n, add 10. And we can swap these around. It's fine to swap that around. So it's 10 subtract 2n. Okay, so our nth term is 10 subtract 2n. We may then be asked something like, what is the, I don't know, the 10th term? Okay, so we could say 10 subtract 2 times 10. 2 times 10 is 20, so 10 subtract 20 is -10. So that's the 10th term. And lastly, we might be asked something like, is negative, I don't know, 68 a term? So we would try and let our nth term 10 subtract 2n is equal to -68. So we could subtract 10 off both sides, so -2n would be equal to -78, and then n would be -78 divided by -2, which is equal to 39. So yes, the answer, therefore yes, it is the 39th term. And we're done. Right, a quick slide where you could try a few of these yourself. Okay, so let's have a look at a quick slide. You try a few of these yourself. For each one, say the nth term, the 10th, the 16th, and the 100th. Off you go. In 10 seconds, I'll show you the answers. Okay, the answers are as follows. So there are the answers for each of these. Hopefully you were able to get them, and we'll finish off with a few exam questions. So each of these, I'll give you 5 seconds, you pause the video, try it, then I'll go through. Okay, going through this one, here are the first 5 terms of a sequence, write down the next. We're going up in 5 each time, so write down the next term in the sequence must be 27, which is obviously 22. Add 5. Explain how you worked out your answer. You add 5 onto 22. Simple as that. 45 is not a term in the sequence. Explain why. Well, there are 2 ways to do it. You could continue the sequence. So you've got 2, 7, 12, 17, 22, 27. You keep adding 5. So your next one will be 32, 37, 42, and 47. So therefore, 45 not in sequence. Okay, you could also say that the sequences always end in 2 or 7. So the sequences, so sequence, the terms in the sequence, terms always end in 2 or 7, not 5. That was an alternative way. Okay, so there was 2 ways to do that one. Simple as that. Nice, easy question. Have a go at another one. Okay, here's the next question. Pause the video. I'll go through it in 5 seconds. Right, so here are the first 4 terms of a sequence. Write down the next term. You're going up in 6 each time, so the next term must be equal to 27. Explain how you worked out your answer. Well, 21 add 6 is equal to 27. You could say the rule is add 6 each time. Write down the 7th term of the sequence where you could keep going. So you've got 3, 9, 15, 21 and 27. So that's the first, the second, the third, the fourth, the fifth. You want the 6th and the 7th. So you add on 6 next, you would get 33. Add another 6, you get 39. So write your answer as 39. J says 58 is in the sequence. Is Jean correct? You must give a reason for your answer. Well, you could keep going on with the sequence and just check. Let's work out the 8th, the 9th, the 10th, and the 11th, let's say. So the next one, adding 6, would be 45, then 51, then 57, and then you'd have 63. So you could write C above, is Jean correct? No. And you could write C above, 57 and 63 are not 58. Something like that. Okay? And you'd be done. And also you could say that the sequence always ends in 3, 9, 5, 1 or 7. 3, 9, 5, 1 or 7. So sequence ends in 3, 9, 5, 1 or 7, not 8. That was an alternative, but probably easier just to continue the sequence. Right, have a go at another question. I'll go through in 5 seconds. Okay, so here are the first 4 terms in the sequence. Write down the next term. You're going up in 4 each time, so the next term must be 19. 15 add 4 is 19 is your reason, and you could state that you add 4 more each time. Now work out the difference between the 10th and 15th terms. I might be tempted to use the nth term here. You could keep adding on, but I'd be tempted to use the nth term. Now you're going up in 4, so it's 4, 8, 12, 16, 4n. Our sequence is 1 less, so our nth term is 4n subtract 1. So I would firstly start by writing our nth term is 4n subtract 1. I would then say the 15th is therefore 4 times 15 subtract 1. 4 times 15 is 60, subtract 1 is 59. Then the 10th term, that's 4 times 10 subtract 1, which is equal to 39. Therefore, if we subtract them, 59 subtract 39 is equal to 20. So the difference, which means subtraction, is therefore equal to 20, and we're done. Right, take a look at the next one. I'll go through in 5 seconds. Right, here are the first 5 terms of an arithmetic sequence. Find an expression for the nth one. We're going up in 6, so we can write the 6 times table above it. 6, 12, 18, 24, 30. The nth term of the 6 times table is 6n. Our sequence is 3 less, so the nth term must be 6n subtract 3. 6n subtract 3. Ben says 150 is in the sequence. Is he right? Well, if he was, 6n subtract 3 would be equal to 150, and we could find n a whole number. Add 3 to both sides. 6n is therefore 153, and then n would be 153 divided by 6. And you could see if that is a whole number. And 153 divided by 6 actually gives me 25.5. Therefore, no, Ben is wrong, as n is 25.5, not a whole number. Okay, and that's that one. Okay, last question then, and in 5 seconds I'll go through this. Okay, so here are some patterns. We've got pattern 1, we've got 2 triangles. Pattern 2, we've got 1, 2, 3, 4 triangles. Pattern 3, we've got 1, 2, 3, 4, 5, 6 triangles. And this one we've got 1, 2, 3, 4, 5, 6, 7, 8 triangles. So pattern 4, we've got 8. You can see we're going up in 2 each time. 2 to 4 to 6, 2 to 4, 4 to 6, 6 to 8. The next one's going to be 10 clearly. How many, so we've completed the table for that mark. How many triangles are needed for pattern number 12? Well, you could keep adding 2. You could see that the 6th one would be 12, the 7th one would be 14, the 8th one would be 16, the 9th one would be 18, the 10th one would be 20, the 11th would be 22, and the 12th one would be 24. Or if you were looking at this really closely, you could see that the number of triangles is always double the pattern number, you see? So the 12th one, we would have to just do 12 multiplied by 2 is 24. Luke says the pattern number 40 has 82 rectangles. Luke is wrong, explain why. Well, because pattern number 40 would have 40 multiplied by 2, which is 80 triangles. Because you double pattern number to get the number of triangles. Okay, and that's everything you need to know for linear sequences, nth term, and using the nth term. Thanks loads for watching.